Hi and welcome. So this time around I've got a series of parts that are somewhat complicated, and they're made out of a difficult material to work with, T316 stainless steel. I've got to make one of these flanges. It's got some 32 thread per inch threads on it, and unfortunately this was the smallest diameter stock that would still fit. They didn't have 4, so had to get 4.5, so I've got a lot of material to come off. This is an igniter flange for a solid rocket that'll be over 17 feet tall and ultimately will go into outer space, which is pretty cool. So I've been tasked with making this part. Got this thing loaded in my 4-jaw chuck, and just so you know, when I was chucking this piece up, I had this piece of wood on here so that in case I dropped it I wouldn't damage my ways. The vice jaws are about almost as far out as I would like to use them comfortably. Maybe another 1/4 inch would be max. They do clear the ways without any problem. So first step, we're just going to face this guy. That's one hell of a surface finish. Now I have just 3/4 of an inch that has to come off of here, just about. So we're going to take some big bites. This is a 50 thousandths bite, 9 thousandths a revolution. This is 100 thousandths depth to cut, 9 thousandths a revolution feed. It was a long, hard road, but we are at our final dimension here. I'm about 8/10 over, so when I get to the final flange I might take some sandpaper on there and just get it down the last 8/10. But now I've got to take this 3.75 and take it down to 1.5 in 1.75 inches. We're going to go in 1.7 for now. Lots and lots of 75 thousandths depth of cut passes. It's going to be like 30 of them, so I'll bring you back. And yes, that glow is glowing chips. This would probably be a good thing for project for flood coolant, but I don't have it set up, so it's making the stainless turn bronze. Pretty chip color. After a massive amount of work, we are at dimension. We are actually a couple tenths under, which should be good. So next we're going to do the relief right here. So we're cutting the smaller section for the threads. Okay, and we're there. And I think that should also be proper thread diameter 2 thousandths over, which is what I'm shooting for here. And that's exactly what we've got. Perfect. So next, I guess I will do the relief grooves. Actually, yeah, next we're gonna do the relief grooves. Oh, I got to do relief for the threads back here. Also, I need a chamfer. Take off some of these burrs, which are hideous. All right, so here's my thinking. Originally, I was going to do the grooves for the O-rings first and the face groove for the O-rings, but I'm thinking now I'm going to do the threads first, because if I screw up this section, I always have more to do, and I could just remove some more material back here and some more material here and still be able to continue on. If I do these grooves, I'm locked in and I have no recourse. And the grooves are, you know, a lot less likely to screw up on the grooves than I am the threads. So we're going to start with the threads, so I'm going to start first with thread relief. Made a total of 35 thousandths deep. All right, so we're going to dial in just a couple of thousandths and do a scratch pass, because this is a really important part, and I should be able to land on any number here. I am going particularly slowly too for my first passes, because I've got to stop in that gap there. Okay, let's get the thread gauge and compare. I don't know if you can see this or not, but I'm using a magnifier and it looks like they line up just right on the money. So we're good to go. All right, so we're going to do another pass. And we're going to take our time with these because I really don't want to screw this up. Normally the first couple passes I'd take pretty heavy, but I need this thing to stay sharp because these are very fine threads. So I am instead taking only a couple thousandths passes per, which maybe, I just don't know how this stuff performs. It cuts pretty hard, so, or it's pretty difficult to cut this 3/16, so. Here's the test fit. We're 2 thousandths away and the test part just starts. So just need it a little bit deeper. I think the 2 thousandths will be exactly right. So I'm down to spring passes. And I normally do spring passes until no material comes off on the pass. And since I've only been going in about 1/1000th at a time, that should be pretty easy to do. Ooh, still a bit tight. Looks like we can start the first 2 or 3 threads. So I was doing the threads and I couldn't get it to mate up with this, and I couldn't figure out why, because I overshot my depth by 3 thousandths, and I thought, man, that's, or 2.5 thousandths, and it's not getting any easier. I was getting like the first 2 or 3 threads every time. So I decided to check the threads on this guy. The drawing specs out 32 threads per inch. This part that it has to mate with, guess what? 28 threads per inch. So we're gonna have to, I'm lucky I didn't do these grooves here, I would have been hosed. So now I've got to basically face this part off right about here, and I'm gonna have to remove more material here, and rethread this guy. So I needed more material exposed, so I pulled the slug out further. And in doing so, I have to realign this. So I'm measuring in and then measuring out and getting them the same. I have to go back and forth because when you bump one, it kind of affects the other a little bit. So we're going to remake this part. I'm going to face this part, which is going to give me my 0. Then I can remove more of this material. I got to take 1/2 inch of that, or 0.45 inches of that, almost exactly. And then I got to pull this back almost 0.45 inches. There you go. And here's the test fit. My threads are just a little bit snugger than the original, but I prefer tighter threads than looser threads. You got a beautiful fit there. It's maybe like 1/1000th difference on that ledge, so that's pretty awesome. Next up, got to put 2 grooves in here, a groove in the face, and then we have to part this guy off and drill 6 holes on a 3-inch bolt circle, and that'll be it for, oh, and we have to drill and bore out the center of this guy too. I forgot about that. That's something he added at the end. As a safety precaution, I put some heavy vinyl tape over the threads, so in case I bump them, because these are really fine threads, so they're probably pretty easy to damage. All right, so we set the left edge of this parting tool, which also using as a grooving tool, on the face of this. That's the 0. So that I'm coming over 0.966, and I'm going to go in 119 thousandths, and then I'm going to come this way back towards the threads, 0.027, and finish for a total thread width of 0.156, because this parting tool is 0.129 wide. I think we got to slow this down. And we just moved over 27 thousandths, that's it. A little bit of rubbing going on there. Just need to relieve the edges of that. And I think to do that, I'm going to use my threading tool because it's got a very sharp point. And I can just take the edges off these. Next up, we're going to do the face groove here, and the face groove has to be very precisely located off of the center axis on this. So I know this is 1.5, right on the money, and so I'm using the zigzag paper here, which is I measured it with my micrometers, and it's about 0.9 something and change thousandths, or 9 and change 10,000ths of an inch. So I just put it in here, slide it up and down until it just grabs, and right there is when it starts to grab. And then I just move in 9 10,000ths, and we're on the money. You can buy zigzag paper on Amazon, although you got to show your age. It's an inexpensive way to measure. Machinists have been doing it for a very long time. I've been using feeler gauges for a lot of stuff, but when you're worried about deflection of the tooling, something that's a little bit soft is probably a better bet. Now I've got my inner edge of the cutter right on the center edge of this part, or 1.5 diameter, or 0.75 radius, and I need to go out an additional 0.055. So we're going to do our first depth at 0.055, and then we're going to come back and do 0.097, which will be the other side of this groove, because the width of my cutter is 0.118, but the groove width has to be 0.160. I've slowed the lathe way down. We're going to see how it goes. This kind of thing is really susceptible to chatter. I want to verify my 0 there, which is good. And we're going to go in 0.106 is the depth. I've come out this direction here to 0.097, which is the other side of this groove, and we're going to go right back in. And now I'm traversing. I went the final depth. I didn't go full depth the first time. And we're done. I really didn't want to risk screwing this up. I've got so much time in this part right now. In case you didn't get a good look at the trepanning tool, it looks like a regular parting tool, except when you see it from the side, you can see it's got a curve in it, and each one of these tools is designed for a specific range of diameters. 35 millimeters to 48 millimeters is what this one is, and I wrote the thickness of the cutter on the side. Makes it easier for next time, because I really hate taking my carbide faced mics and putting it across this carbide face, because it can scratch them because they're the same material. So I really hate measuring it. I've got a pair of manuals I use for that, and save my really good Michi-Toyos for my precision work. Next up, we just have to drill a hole all the way through the part that's 7/16 in diameter. Ultimately, I believe that will get something like a 1/4 NPT tap put in it, and they'll be tapped by the customer. And then I need to relieve this side 3/4 inch diameter down 1.5 inches. And since I probably want a flat bottomed hole, I'm not sure what the relief is for, but it's not spec'd as being precise. So I am going to probably use an end mill for that. I'm actually drilling one size under 7/16, and I will follow up after I remove most of the material with a reamer. I think I'll have a hard time holding a 3/4 inch end mill in a chuck down here. So what I'm probably going to do is I'm just going to remove a good chunk of the material. This is a 9/16 end mill, and we're going to go in, I want 1.5 inches total. We're going to get close and we'll bore the rest. Decided to go up one more tap size to 5/8. Because this is a very efficient way to remove a lot of material. Alright, so over here at the bandsaw, I've got a large C-clamp, as you can see here, and I've got this wide flange V-block I made a long time ago to hold it in place, and I'm also holding carefully with my hand, but I got to keep it down, and I don't have a clamp that could reach around this way and push down as well, so I'm holding it down with my hand, the other hand on this part, and just going very slowly. So this is the parted off part, and I need to hold it by this precision surface here. So I am going to create a sleeve that fits over the 1.5 inch part of this, and it'll be split, and then I clamp with the forejaw and it should hold it right in place. And I can obviously get it centered with the forejaw too, so even if it's not perfect, I can compensate, but at least I won't be holding on the important material. Last pass, kind of boring out the center. All right, so I stopped and I got really close to the number, and it looks like I nailed the number. Look at that, that's a no wiggle fit. So next up, we're just gonna part this guy off, round over these edges, make it clean, take it over the bandsaw, cut it in half, and just on one side to make it split. Alrighty, last 2 steps on the lathe here. I wanna chuck this guy up, but I don't wanna grab on this surface. So that's where I made the split bushing, and I made a little relieved side just to let me know which side was supposed to be on the thread side. And it sticks out farther than the thread, so I could use this to ship if I wanted, just to protect this part. One thing I needed to make sure I did, maybe you can see it over here, is I needed to make sure the split was between jaws. So I loosened up briefly and reoriented it, and now we just got to dial this guy in. Last step is reaming out the hole to the final size, and this was absolutely not a requirement. I just thought it would give a better finish, so this is a step that was not necessary. Which I think it did give a much nicer finish than the drill bit did, so I like it. Alright, last step here is to do the bolt circle, so I need to find the center. And to get close, I have this ground piece of high-speed steel that I did on my surface grinder as a centering point, and you just keep lowering it a little bit, getting the sides even, lowering it a little bit, getting the sides even in both directions, and you can get very, very close. I am going to use the Blake coaxial indicator or my indicator on the spindle here to get it dead on. But this should get it very close. I'll be curious to see how close it gets it. So I'm going to zero my X and Y now, and we'll get the Blake on there, or the Blake clone, and see how close we got. So I might have gotten really lucky with that method, but it's within about 1/2 thousandth. Actually, it's not even moving. Less than 1/2 thousandth. That's a surprisingly good location find for a center find. I probably just got lucky. Probably that won't happen again. I'm sure everyone's seen plenty of bolt hole circles done before, and so I'm not going to show too much of this. I'm just going to whip through it. Last step, just chamfer. Alrighty, so we're finally done with this part. All told, took about 9.5 hours. Should have taken about 6.5 hours, but the threads were mislabeled or misrepresented on the drawing as 32 threads per inch, when in fact they were 28 threads per inch. Fortunately, I had the mating part so I could identify that, or I would have lost everything. So there's the whole part completed, and these little, what look like scratch marks on here are just actually the aluminum coming off, and I'm going to leave this on it to ship it because it'll protect the threads, and they can just pop a screwdriver in there and pry it off. So we are done with part one. There's some other parts that he wants me to make. We'll see if he gets the drawings and if that actually ends up coming to fruition. Whoops. I made this such a perfect fit, it's hard to get off. So here's a close-up if you wanted to see. You know, like I said, I'm going to leave this on it to ship it. Thanks for watching. Hope to see you next time.